People are often confused how to draw a face-centered cubic unit cell um, given a lattice. For example, in the workbook we were presented with a series of cubes like this. There's 8 individual cubes, 4 on top, 4 on bottom, arranged into one large cube. Now if you're going to try to draw a face-centered cube, how do you approach the problem? Do you use one of these little tiny cubes, or do you use the whole thing? On a recent PSA I said use the whole thing. So looking at this, I'm going to call this the z-axis. There's an x, y, and z axis shown here. And I'm going to slowly add atoms to this. But first of all, I'm going to show you how to treat the whole thing as one giant unit cell. So what I've done here is highlighted just one of these small cubes in the bottom layer. And I think you can see there, but if we just move them around, the yellow around, it would be 1, 2, 3, 4 in the bottom, and 8 more. Now if I was going to try to make a face-centered cubic unit cell using this little cube, I'd have to have so many atoms around here it would be very confusing to actually see. Instead, we're going to use the whole structure as one unit cell. So that's highlighted here. Again, now the whole thing is going to be used as a unit cell. Again, the z-axis is in this direction. There's going to be a bottom layer, the middle, and the top. That corresponds to z being the 0. We're going up halfway, so we'll call that 0.5. And when we get to the top, we'll say that's 1. Now I'm going to slowly add atoms to this one large unit cell. So let's start off with adding, we're going to make the face-centered cubic unit cell. Let's add atoms or ions, depending on what you want to use. So let's call these atoms to the corners. And of course, there's 8 corners in this very large yellow unit cell. 1, 2, 3, 4, 5, 6, 7, 8. Now, of course, this is only one unit cell. Each corner atom would be shared by 8 other unit cells. So remember, only 1/8 of each one of these contributes to the unit cell. Given that we have 8 corners times 1/8, there is effectively only one atom contributing to this unit cell. Okay, now let's look at this sort of z-axis dimension. If we look at this bottom layer, we'll call that z equals 0. Look where the atoms are looking down on top of that bottom layer. You could say I have one atom at each corner of this little square. This middle layer here, halfway up, we'll call it z is equal to 0.5, has none. And at the very top, we have a square composing the top face. That would be at z is 1. And you can see we would see 4 atoms at that level. Okay, let's add now atoms to the faces. And obviously there's 6 faces. I've shown these in red. We'll pretend they're the same as the gray ones for right now. So we have top, bottom, left, right, front, back. So that's how you draw on this larger unit cell the face centered. And of course it makes sense to use the whole unit cell that's presented here. Then the atoms can be drawn in one of these faces, and they're very easily seen. Now let's look at this little associated Z diagram. If we look at this bottom layer now, from a top-down perspective, you see we'd have one atom at each corner and then one in the middle. Likewise, this second halfway up layer, now you can see we don't have any things in the corner, but we have them, it looks like on the edges, but in this diagram they would be in the actual faces of the one large unit cell. And at the very top, again, we'd have something that looks like this in the top layer, one at the corners and one at this face. One last thing we could see is, let's look at where a tetrahedral hole, because face-centered cubic unit cells have octahedral holes, one in the middle and one at every edge, but they also have 8 tetrahedral holes. Here's an example here. I've highlighted just one of these cubes. And if I were to suspend an atom in the middle of that cube, it would be close to 4 other atoms. This one, if this is in the middle, this is coming out. This one over here that was in the face is coming out. And then because this is in the middle, this would be connected to this one going to the back and this one going to the back. And of course, all those are in this small little cube. So, and of course, there would hence be 8 tetrahedral holes, 1 each in each of these little cubes that make up this one large face-centered cubic cell.